Hello everyone, we are back with another quick tutorial. Wait, what am I supposed to be doing? On estimated standard error. So before we can get to estimated standard error, we have to talk about the difference between a distribution of individuals and a distribution of statistics. In this case, a distribution of sample means. And so we're going to have differences between these. So far, we've been operating in a distribution of individuals, whether that be a population, like you see in image A, whether that be a sample, like you see in image B. But we've been dealing with regular, just individual people, and that is what we're dealing with. But when we make comparisons for hypothesis testing, one of the things that we're going to need to do is see how likely it is that our sample mean could be obtained by chance. And so to compare our sample mean, we have to compare our sample mean not to a distribution of individuals, not to a population, but to a distribution of sample means. We have to compare means and means. And so a distribution of sample means is a collection of sample means for all of the possible means that we could have in a particular population. That is going to be based on our particular size of those samples. So if we have a sample size of 10, we're going to have a distribution of sample means for a sample size of 10. If we have a distribution, we have a sample size of 100, then we'll have a different distribution of sample means that will be for a sample size of 100. And so, again, a distribution of sample means is really a special kind of population. It has all of the possible random samples from a particular size, from a particular population, and it contains all of the possible samples. This is a distribution of statistics, not a distribution of scores. So far, we've only been dealing with distributions of scores. Now we're dealing with distributions of statistics. So previously, we've been in population world where we have a distribution of individuals. But if you think about those measures of central tendency, what they do is they pull everything into the middle and describe that data using one number. And that mean, again, we've talked about, is that balance point. And so those outliers affect that mean, but everybody kind of clusters around that central point. And so when we have a distribution of sample means, our distribution gets skinnier. We're still going to have that same central point, right? We don't see a difference kind of in those central points on those distributions. And so what we're seeing is that our mean of our distribution of sample means will be the same as the mean of the population of individuals. But because we are dealing with statistics and not individuals, our variance and our standard deviation is going to be smaller. It's not going to have as much spread. And the way that we can quantify how much spread it has is we'll divide that population variance by our sample size. Again, because each distribution of sample means is based on a particular sample size. And so that n will be really important here. So we can also then take the square root of that variance and get that standard deviation. So this is the formula that is on your formula sheet. And you can see there's a lot of different ways to get this value. You can do it using our standard deviation, and then you would divide it by the square root of n. You can do it using our variance of the population. You can do it if you already have the estimated variance for the distribution of means. Any one of those ways will get you to the standard deviation of a distribution of means. Because saying a standard deviation of a distribution of means is really, really hard, it actually has a special name. And that special name is standard error. Standard error is telling us how well an individual sample mean represents an entire distribution. And so this will actually start to quantify what kind of sampling error we might have, what kind kind of how well a score is expected to be, these kinds of things. And so this value is going to be very important. It's not hard to calculate based on what we've been doing so far. It's just one step further. But this, it's either called standard error or estimated standard error. This is a very important statistic that we will use moving forward. So to practice calculating those, here are the practice problems that we had in class. Our standard deviation of 4, and an N of 4, variance of 400, and an N of 16, variance of 49, and a N of 25. And to look through those answers, again, we can do this in a number of different ways. If we have that variance or that standard deviation like we do in practice problem 1, we can just take that standard deviation and divide it by the square root of n. So that would be 4 divided by the square root of 4, which would equal 4 divided by 2, which would give us an estimated standard error of 2. If we're given the variance of 400 divided by that sample size of 16, then we'll take, that's 25, we'll take the square root of that, and we'll get an estimated standard error of 5. If we have a sample size of 25 and a variance of 49, 49 divided by 25 is 1.96. We take the square root of that, and we have an estimated standard error of 1.4. So this is actually a really easy calculation. It's just going to be a very, very important calculation, because when we're dealing with distributions of means, they have a different kind of spread than those distribution of individuals. So this ends our quick tutorial on calculating estimated standard error. Thanks.